Well, today we are going to start with a problem, latent heat and specific heat problems. Here is the question: how much heat energy, is required to convert 10 gram of ice at minus 10 degrees Celsius to 110 degrees Celsius? So the values are given: mass 10 grams, specific heat of ice, latent heat of fusion, specific heat of water, and latent heat of vaporization, and specific heat of steam. These values are available. How are we going to understand this problem and solve? Look at this graph. You can see here, this is a melting point of ice, 0 degrees Celsius. And this is a boiling point of water, 100 degrees Celsius. In the calculation, we have to do from minus 10 to 0, first step, how much heat is absorbed using specific heat of ice, 2.1 joule per gram. At 0 degrees Celsius, the temperature will not increase, but heat is absorbed in the form of latent heat of fusion, that is 334 joule per gram. The next step, from 0 to 100 degrees Celsius, using specific heat of water, which is 4.184 joule per gram, we have to calculate how much heat is absorbed during this period. And at 100 degrees Celsius, the boiling point, we use latent heat of vaporization, which is very high, 2260 joule per gram. And then the last step will be above 100 degrees Celsius. The amount of heat absorbed from 100 to 110 degrees Celsius using specific heat of steam, 2.01 joule per gram. So these are the values, and using these values we can calculate with a simple problem. You need to understand here the latent heat of fusion of ice and latent heat of vaporization of water. The big difference is there. So this much energy is being supplied per gram. We'll go to the problem in the next slide. Okay, this is a step we are going to do. First one, how much heat is absorbed between minus 10 to 100, minus 10 to 0 degrees Celsius. The next step, at 0 degrees Celsius, using latent heat of fusion, we are going to calculate. And then the next step, from 0 to 100 degrees Celsius, how much energy is absorbed. And using latent heat of vaporization, how much heat is being absorbed at 100 degrees Celsius, the boiling point of water. The last step is between 100 and 110, using specific heat of ice, we're going to calculate. Now you can see here mass and then specific heat of ice, change in temperature. Change in temperature will be 10 degrees Celsius here. And the second step, mass into latent heat of fusion value, we are going to substitute. The third step here, mass, specific heat of water, and change in temperature. The next step, at the boiling point of water, mass into latent heat of vaporization. And in the last step, mass, specific heat of steam, and change in temperature, 100 to 110 degrees Celsius. This we are going to substitute these values, 10 into 2.1, and this will be 10. And here 10 gram into 334 joule per gram. Here 10 into 4.184 joule per gram, and the difference is 100. And here mass into latent heat of vaporization, 2260. And then 10 into 2 joule per gram, and the difference is 10. If you substitute these values, you will get the final answer will be 30,534 joules or 30.534 kilojoules. So that's the answer for this.